It's a offline based recording, so I'm basically recording the screen here, right? So let's commence. I guess there are 13 students here now, and more are likely to join in. If and when they join, I'll admit them. So presently the provision is that I have to admit them manually for some reason. It's not automated. So I'll join them as and when they join. So there might be some popping sounds, and that might disturb you guys in the midway when they are joining. So please try to ignore that. Uh, yeah. Apart from that, as I have told, my name is Aditya, and this is the this particular presentation or whatever you can call it, the live session interaction is to facilitate you all guys to ask questions from the previous rolled out assignment in this particular coursework. So if you have any particular doubt in the rolled out assignments, you can ask them now. So for your convenience, I'll just be sharing my screen and then projecting the previous rolled out questions on this platform here. Yeah, so I hope all of you guys are having access to this weekly assignment, right? Can one of you please unmute yourself and mention if you are having access? Yes, sir. Good, 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 good. Uh, Let me also join in via my mobile so that I can see the text as I talk to you guys. So that would be convenient for me. Uh, Calendar. Yeah, so let's commence the meet now, right? So for the assignment number one, let me discuss the question number one here, right? So I'm just assuming that we'll go forth and based on your feedback and then your opinions, I'll do what's needed, right, to address this interaction session in a more robust and more interactive manner, right? Okay. Yeah. So, yeah. So, the first question is before I commence, are all of you from the first year undergraduate courses, or some of you are from other diploma courses and second year or third year, something like that? Is there anyone else here from other than first year BTech course? Okay, no. So I take it that everyone here is from first year. Uh, so let's commence. The first question is related to figuring out what is the ratio of two resistance, right? So you have been given a wire A and wire B, right? And both of these are having some parameters. That is the value of L, rho, and diameter D is given, right? And you have been asked to figure out their ratios, right? So it's a very straightforward question, and all you got to do is use the formula, right, of resistance, which is R is equals to rho L upon A, right? Uh, wait, right, so you can use this formula to figure out the value of the resistance, right? So the value of resistance can be determined because rho will be fixed for there's another no, the rho is also not fixed, so the rho in the first case will be just be rho, right? And the L will be equal to the L which is mentioned, L, right? And the area will be equals to you are considering it to be a circular cross-sectioned wire. The area will be nothing but pi r square. So instead of r, what these guys have given is a diameter d. So you can replace the r with the diameter d here, right? And it will be just 4 times multiplied here. So you have d1, you have the d will remain the same. So in the case 2 also the formula will remain the same. The only thing is different. The difference will be you have to plug in different values. And after plugging in the values, you can figure out the ratio of RB is to RA. So here's a solution, the exact solution on the right hand side. You can see that the ratio of RB to RA will be equal to 1 is to 1. So the idea here is that you just have to use this basic formula of resistance, right, rho L upon A, and then plug in the parameters with what the question has given, and then you can figure out the solution. So is there any doubt in question number 1? Is it clear to all of you? Right. So in that case, let me switch on to the next question, which you guys are having. So the second question is related to an infinity ladder kind of a question. So what you guys have here is a repeating sequence. So this particular block here, the one I'm just marking, highlighting here, is repeating, right? So what you guys can do is actually what you guys can do is actually figure out instead of this particular thing, what you can do here is that you can just write here, this is 1 ohm and this is 2 ohm, right? So instead of this, I can also write it like 1 ohm, and then 2 ohm, right? And then again it will repeat 2 ohm, 2. So if you see here, this particular section is same as that of the input section, because I know that this is, you are just you are using the property of an infinity, that is infinity plus anything is just an infinity number, right? So if the input here was Rn, the input here is also going to be the same value. Right? So this is the idea, basic idea which is used in this particular question, that you should be able to truncate this infinite circuit into something which is countable, right? So you can replace this Rn, R input, by a suitable network which is represented on the right hand side. So instead of putting this infinite circuit over here, what you need to do is, this Rn was shown to here, right? So you can just replace the infinite circuit here by a constant Rn, right? So you now have a circuit which is, so you now have to figure out the value of what is the effective resistance across these two ports, port number 1 and port number 2. And for that, it's basic resistance addition. So these two are in series. So these two will be summed together. Then it will be in parallel to our the 2 ohm resistance, which will come in series with the 1 ohm resistance, which will be equal to Rn. So there will be an algebraic equation here, which is represented in this particular formula, right? So the Rn is coming in parallel with the 1 ohm, which is coming in series with the 1 ohm, which is coming in parallel with the 2 ohm, like I said, and it's getting added to the 1 ohm here. The total value will be equal to the Rn. So you just solve this equation and then you can figure out what the solution is going to be, right? So the solution here is going to be 2.2, right? Which is, or rather 2.236, which makes the solution lie in this region B, right? So you can check the answer B as the correct answer. So is there any doubts in this particular question? Did you all understand it? Okay, I guess there are no doubts in this particular question. I think this is very similar to what you guys have been doing previously also in your high schools, right? 12th standard. So you can get these kinds of questions in many of the competitive examinations which you guys might have written before, right? So it's very similar to the same concept which you have been taught in your earlier classes, right? That is a reduction of resistances. Uh, let's proceed on if there is no doubt here.
Excuse me, sir. Can you please explain again?
Pardon, I did not get that.
Sir, please explain it again, sir.
Oh, explain it again. Okay, sure, not a problem. So
Thank you, sir.
here, here, what's the question? What's the question asking you? You have to figure out the value of this resistance Rn, right? So how do you get a resistance Rn of an infinite circuit? If you'll see, you cannot get the value of this resistance until you reduce it to a countable number of resistance, because here it's infinite number of resistance. So you have to get something which is countable, something which is which you can put in series or parallel and then kind of get the sum of, right? So the resistance here, the 2 ohm, you can split it as 1 ohm and 1 ohm, right? And
Okay.
then if you'll see this 1 ohm resistance and 2 ohm is and then the subsequent resistance are forming the same type of network as is the input from this end here, right? So if this
Okay,
was
sir.
Rn, then I can also label this entire network as Rn. Did you understand that?
Yes, sir.
Yes. So that is what has been done here. So the 1 ohm from here is kept as 1 ohm, right? And the 2 ohm is split into 1 ohm and 1 ohm. So 1 ohm is retained, 1 ohm is retained. And the subsequent part of the 1 ohm and 2 ohm, this particular network is replaced by Rn, right? Because the entire network, as I said to you before, is same as that of Rn, right? This was an infinite circuit. This is also an infinite circuit with the same magnitude of resistances, right? So you can replace this entire block with the same value of Rn. So if this was Rn, this is also Rn. You get it?
Yes, I get it, sir.
Right, and then you can utilize your basic series and parallel circuit to figure out the value of the Rn. You get an algebraic equation which is represented here, and based on that you can get the value of Rn to be of this particular value. Is it clear now?
Yes, sir. Thank you, sir.
Good. So yeah, that was question number 2 for you guys, right? Um, Let me move on to question number 3. In the question number 3, it's a it's a question of what is the magnitude of power, right? If you have been given a particular current and a voltage. So we all know what's the formula for power. How do you represent power in electrical circuit? You write I into V, I T V T. This is how you do it, right? So if you have been given a formula of Vt, which is a function of I, so here Vt is a function of It, correct? So what you need to do is just put it in there, right? So what's the formula here? It's 5 di by dt. So what's the formula of I here? I is 10 e power minus 2. So it will be 20 e power minus 2t with a minus sign, right? And then yeah. And then what you need to do is you need to multiply it with the value of current, that is again 10 e power minus 2t, right? So from here you can get it as 100, 100,000, 1000 e power minus 4t with a minus sign here, right? And then what you can do is you can just put the value of the current, they are asking you at time instance 1. So you can put the value of time is equals to 1, and then you can figure out what's the value of the power is, right? After that you will get it. So the detailed solution of that of the same is represented over here. So you can see here that in the solution what they have done is that they have figured out the same answer, that is minus 1000 e power minus 4t, and then they are substituting in the value of time as 1 second, and then you are getting the answer as 18.31, right? And then you have to figure out where it lies, and then you have to just select that. So the point I want to draw your attention to is always remember that power is equals to V as a function of time, I is a function of time, right? And then you have to use it. If I'll ask you what's the definition of an energy, so it's power over dt integral, right? And this you will integrate it over time. So there will be something the time will come if you are figuring out energy, and then power will come if it is energy per unit of time, right? So you have to understand that there is a difference between power and energy. Your house power comes in energy. Your house meters are rated in energy, that is kilowatt hour. And then your bulbs are rated as 60 watts or 100 watts or whatever. So you have to understand the difference between these two concepts here. That's the entire, I think, the motivation of asking this particular question, and then just the basic formulas will yield the answer. Is there any doubt in this particular question? Okay, if there are no doubts, let me just move forward. So a battery charger supplies a constant current into a 100 volt battery for 2 hours. If during the process the amount of energy supplied is 4 kilowatt hour, then the current drawn by the battery is. So it's a very straightforward question based on the idea I just talked about in the previous slide. You have the energy which is given to you, you have the voltage which is given to you, you have the current, you have to figure out no, the current is not given, the time is given, you have to figure out the current. So it's a simple algebraic equation that is the energy divided by the voltage divided by the time, that will yield the value of the current. So this is what has been done here, right? So the energy, you took the energy, you divided with the time, you got the power, and then you divided the power with the voltage, you got the current. So thereby you will get the correct answer as D, that is 20 amperes. So is there any doubt here in the understanding of what is power and what is energy? Okay. So it appears that there are no problems here in understanding the concept. Okay, so just let me move further. So this is a question regarding the load line. Load line is, what is load line? The curve which will be representing the voltage and the current the current dynamics in the load is the load line, right? So you can write here that the voltage across this particular load will be equal to V, and the load line is giving you this particular the equation of the load line is given to you as this. So you just have to plug in the value of voltage here. So I know that I will be just I, and V is nothing but I into R, and this is given as 50, right? So you just have to take it out, and this will be equals to 50. You have a value of resistance of 4 ohms, right? And then you can just divide it to get the value of current as 10 amperes, right? So this will give you the value of current as 10 amperes. So pretty straightforward here, I think. So is there any doubt here?
Clear, sir.
Sorry, I did not understand that.
Clear, sir. Clear, sir.
Clear. Okay, that's good. So yeah, that's the solution here. Correct answer is A. Then it's asked to determine the maximum voltage that can be applied across the series combination of 154 watts, 100 ohm, 2 watts resistance, such that the power rating of either resistance does not exceed the limit. Yeah, so how do you define what's the maximum amount of power which the particular resistance can take, right? So if the resistance is there, then somebody wants to join, right? So if the resistance is there, then it can take a maximum value of current, right? Above which it will just melt down, right? So the maximum power is going to be determined in a series combination by what is the maximum current you can, if you have a R1, R2, R3, and so on up to Rn, right? R1, R2, so on up to Rn. Then the maximum current in this particular series connection is going to be determined by what is the least value of Imax which any of these resistance can support. So let's suppose Imax of jth resistance is the minimum. Then that particular resistance is going to determine what is the current which can flow in this particular network here, right? So all you have got to do is figure out which amongst these two, the resistance R1 and R2 here, which amongst them the two is of lower current value, right? So the power is given to you. I know what's the formula of power related to I square R. All you got to do is figure out the individual current of these two resistance. So in the first case, it will be 4 upon 150 square root, right? And in the second case, it will be 2 upon 100 square root. So you figure this out, and you will then be able to figure which is greater. Is this greater than this, or the opposite way? And whatever the case be, then you know what is the maximum current you can just pump into the system, and then you just sum up the resistance and you multiply it with the deduced. I deduced will be equal to the Imax of minimum of these resistance, right? Deduced square into R effective, right? So this is what has been done here. So you see here that there is a resistance 150 and 100, 4 watt and 2 watt respectively. So you figure out what is the value of current. So 0.16, and case 2 it is 0.14. So 0.14 is the one which is dominating here, right? So it will, because it's smaller, so you just take the value of 0.1, and then you can figure out what is the effective power loss in the particular network. So what does this question ask? Maximum voltage in volts. So volts also you can determine. So if this is the current here, then I into R will be the voltage across the network and R will be given as the sum of these two resistance. So sum of these two resistance into this current, so it will give you the voltage. Uh, I hope what I have just mentioned was clear to everyone, right? If there are any doubts, please ask.
Sir, what is the difference between electrical power and electrical energy?
Okay, so electrical energy per unit time is electrical power, right? So as I just mentioned, if you'll see it, like you have been seeing it in your the receipt which you'll getting in your homes, right? The electricity bill. It is mentioned kilowatt hour. So that is a unit of energy. When you are seeing it in the bulbs or in the motors that you are using at house, the pumping motors, right? So that will be rated in kilowatts, right? So it's kilowatt. When it's mentioned kilowatts, that's electrical power. When it is mentioned kilowatt hour, that is electrical energy. So there is a unit of time which is coming, which when gets multiplied with the power, it gets converted into energy.
Okay, sir, clear. Sir.
Okay, okay. Um so yeah, that was also asked in one of the previous questions. One of it was based on that. So if there are no questions, let me just carry forward here. It's been asked in this particular question that you have to figure out the total charge which is passing through the element. So the y-axis here is the current and the x-axis here is the time, and hey, just a minute, just a minute. It's still recording. That's good. Um yeah, somebody wants to join. Correct. So it's been asked to evaluate the charge here. So I know that uh, charge Q is nothing but integral I dt, right? So all you have to do is figure out what is the integral of time as a function of like integral of current as a function of time. Or in this particular case, since it is the graph is very simple, you can just figure out the area under the curve, which is nothing but the integral, right? So if you'll figure out what is this area represented by the thatched red line, you will be able to figure out what is the coulomb, right? From 0 second to 6 seconds, right? So this is a triangle, so you can just say half height into base, and this is a rectangle, so like A cross B, and then again this is a rectangle, so you can just call it C and maybe call this as D. So C cross D, and again this is a triangle, so half height into base, right? So you can just split the circuit, split this diagram up into smaller sections, and then compute the area under the curve to figure out what is Q, right? So it will give you this. So using the same thing, the area under the curve has been figured out. So what I have done is I split this particular circuit into different cross sections here, right? And then I have determined the value of the charges in the various sections to determine the overall charge to be equal to 760 coulombs. So so is this clear to all of you guys? Did you guys understand the solution? Okay. Okay. So if there are no queries here, let me just switch the slides to a new question. So this question asks you to determine what is the power delivered or absorbed by the voltage source in the given circuit below, right? So what happens is that a voltage source can absorb power and a voltage source can release power, right? If the current is being fed by the voltage source, it will be giving power, it will be delivering power. If it is absorbing some current, however, it will be absorbing some power, right? So based upon the direction of current, you will be able to evaluate what is the power, if it is being absorbed or if it is being released. So that is the first step. So uh, what's the voltage across this particular source, because the voltage here is not mentioned, right? However, you can see here that the current in this particular branch is mentioned. So this is 3 amperes and this is 2 amperes. So therefore, using KCL, I can write the current entering in this particular node will be nothing but 5 amperes. Correct, guys? And so somebody is asking, can we get the recorded session, recording of this particular session? So yes, you can get it. Actually, after this particular session, I'll be uploading this particular recording on the YouTube platform. I guess all of you would have been given the link to the YouTube by the NPTEL team, right? It has already been communicated to NPTEL. So on the mentioned YouTube channel, you can get the access of the recording of this particular session, right? So so even if you have joined a little late, like you won't miss the things which are being discussed here right now, because it will be available. However, for the purpose of interaction and getting your doubts personally cleared, it would be better if you can join it at the start of the session, right? So either with me or there is another TA, right, who would be taking up the same thing once again. So you can join it on her session as well, and she'll be able to clear the doubts. So yeah, so I think you would all be aware of those things, and NPTEL team would have apprised you of those details. So let me come back to the questions here. So I was talking about KCL at this particular node. What you do is you figure out what's the current here, you figure out what's the current here, and then you add them up to get the current over here. So it's 5 amperes here. And you can figure out what is the potential across these 2 points. So if you'll just move in this particular circuit, right? So this is minus, if you'll move in this direction, it is plus 60 and then minus 100. So basically the voltage across here is, you can replace this particular thing, and then you can say the effective voltage across this this particular thing will be equal to plus 40 volts, right? Because this 60 would be negated from this 100 volt, and you will be left with 40 volts, right? 40 volts. So what you got to do is, what you got to understand is that 40 volts must be equal to 40 volt, because if you cannot connect two different voltage sources of unequal magnitude in parallel, right? So if this is 40 volt, this has to be equal to 40 volt, the sum of these two. But what is this? This is Vs minus 80, and then you are saying that something is happening. You are saying that it has to be equal to 40. So from here you will get Vs as 120. Apologies, something is happening. And then you multiply it with the value of current. So it is 5 amperes as you have evaluated, and you will get the value as 600 watts. This will be power, right? V into I. This is V. This is the V you have evaluated, the Vs, and then you are multiplying it with the current here to get the power as 600 watts. And then since the current is exiting out, it is power delivered. So the answer would be C. So this here on the right hand side is a detailed evaluation of the things which I have done, right? So you are figuring out that the solution comes out to be the third one, right? So is there any doubts over here? Okay. If there are no doubts, let me just proceed forward. So which of the circuit is valid, right? So this is asking you regarding the validity of the circuit here. So let's take them up one by one, right? So here in the first circuit, if you'll see, the voltage here is 8 volt, right? And on the right, it's showing that Vs is 2 times V1. So this has to be 16 or something like that. So any of you can any one of you unmute yourself and tell me if this is a valid circuit or not? Like any of you can unmute yourself. Just let's try to make it a little more interactive, because this is a interactive session, right? So I can like feel free to voice your opinion, ask your doubts, or give out some insight into the problem. Like I'll encourage that. So one of you just unmute yourself and then tell me if this circuit is valid, invalid, and the reasons for the same. Okay. I guess none of you are unmuting yourself. That might have to do with your fear of speaking on a public platform, something like that. So I'll encourage you all guys to speak, right? Don't shy away from voicing your opinions. It's good for a healthy conversation, right? But then regardless, like we'll interact in the days to come. If you are not comfortable now. So let me just tell you why this is valid or invalid. So as I was telling, you cannot have two voltage source of unequal magnitude connected in the same circuit. So if it is V1, if it is V2, then V1 must be equal to V2, right? Both in terms of magnitude and in terms of course, in terms of magnitude, because this is a DC network. Uh, So, is this principle clear to all of you guys? Okay. Can I have
Sir,
two currents in parallel? Okay, somebody is asking a question. Yeah, go ahead.
sir, why we don't connect like that?
Okay, question is why? Okay, that's a good question. So, question is why can't we connect? Okay, let's suppose hypothetically you connect these two voltages, right, in parallel of unequal magnitude, and the resistance here is nothing but the wire resistance, and just assume that everything is ideal. So, the wire resistance is equals to 0. All right. So what is the current which is going to flow out of one of these voltage source? It will be V1 minus V2 divided by R resistance, right? And what's the magnitude of this going to be? It's going to be infinity for an ideal case. Understood? So what is going to happen is that there is going to be very high value of circulating current which will just burn out this particular interconnecting wires, right? In ideal case, it will be infinity. In a practical case, it will be limited by what is the resistance of these interconnecting wires. So usually the interconnecting wires will have some value in few milliohms, right? The R resistance will be few milliohms, of the order of few milliohms. And depending upon this difference, you'll get the magnitude of this particular current, which is still going to be very high. So even if it does not burn the wire, it will just heat up the wire a lot, and it might not burn instantly, but then with the process of time, it will just degrade, and it might give away, the insulation might give away in few hours or few days, depending upon what's the internal resistance. So that is why you don't connect the two voltage source with unequal magnitude in parallel. So did I answer your query?
Yes, sir.
Okay. So based on that, the same person who had asked that query, please tell me that is figure number 1 valid?
No, sir, is invalid, sir.
Why is it not valid?
Sir, figure A.
Right. Figure A. Why is it not valid?
Because, sir, both voltage sources are different, sir.
What's the voltage source magnitude of the second one? The dependent voltage source. What's the magnitude?
Sir, 2V1.
Okay, so that is basically 16, right? So you cannot connect these
16.
two, these two in parallel. That's the idea, right?
Yes,
So
sir.
so yes, that's correct. And how about the second one? Is it correct? So anyone here, what's the logic you need to apply here? So the logic, I'll tell you what's the logic. The logic is you cannot have two different current sources in series, right? So you have a current source, let's say of 2 ampere magnitude, and then in series you are connecting another current source of, let's say, 5 ampere magnitude, and you are connecting some resistance over here, right? So now the KCL is not being followed, right? So whatever current is being ejected out here, the same current must be passing out from this particular network here. So if this is 2 amperes, this has to be 2 amperes. If it is not 2 amperes, then this is not a valid representation. So what is going to happen here is that one of the current sources will cease to be current source. So you learn in the days to come that these current sources are designed using some configuration of BJT, right, or CMOS circuit, right? So this, how do you design this current circuit? So what is under the hood here, right? So under the hood, you will figure out that these are nothing but a circuit of a BJT or a CMOS, right? Some transistors. So you might have heard of the word transistors in your higher school, right? BJT, these kinds of terms you might have heard. So it is being designed using these kinds of circuit elements, right? So what will happen here is that one of these current source will cease to be a current source. Whichever it is dominating will dominate, and the other will cease to be a current source. And then that is going to happen in the practical scenario. But mathematically speaking, you just cannot connect two current source in series, and that is an invalid scenario. So just look at it here and tell me. Maybe let me just call out a name. Yeah, so Sandeep is here, right? So Sandeep, why don't you unmute yourself and then tell me if it is a valid circuit or not, the figure B. Okay, perhaps Sandeep is not able to unmute yourself. Anyone else wants to take a guess here? Why figure B is valid or invalid?
Sir, it's a invalid, sir.
Okay, why do you think it's invalid?
Because sir, two current sources are in series, sir.
Right, and what's the magnitude of those two current sources? One is
Sir,
3,
one is 3 ampere.
right,
Yes,
and
sir.
other one is,
Sir, V1 upon 2, sir.
right, and what's the magnitude?
Sorry,
3.
Right,
sir, 3,
so
sir.
right, so both the current source, one dependent and the other independent, are of the same magnitude, right? 3 amperes and 3 amperes, correct? Am I correct?
Yes, sir.
Right, so it should be a valid circuit, right?
Yes, sir.
Right. So uh, yeah, so all of you agree with your friend, right? When he's saying that it's a valid circuit, right? Is there anyone who is not agreeing with your with the remarks of your friend? Okay, that's great. So figure number B is a valid circuit. Now let's come to figure number C here. So what's happening in figure number C? You have a current source, right? And you have a voltage source. No, you have another. Yeah, you have a voltage source, dependent voltage source, which is dependent upon the value of current here, right? Independent current source, and you have a resistance over here. So, does anyone wants to take a shot here and tell me if it is valid or invalid? See, the basic KCL and KVL should be followed. If it is being followed, it's well and good. If it's not being followed, something is amiss. Right. So none of you wants to take a shot here. So just let me explain here. Vs is nothing but 2 times I1. So what is Vs? It is 2 into 2, that is 4, right? And I know that the potential across this particular resistance, 10 ohm resistance, is 4 volts. So what is the current which it will draw? It will draw a current of 4 divided by 10, that is 0.4 ampere magnitude, right? And I know this is zero point 0.4 now after my calculations, right? I also know what is the input current at this particular node here. So input current is nothing but 2 amperes because this is a constant current source of value 2 ampere, and it will just force out the current 2 amperes at this particular node. Now I know that KCL is valid, so 2 amperes is coming in, zero point 0.4 is going out, so 1.6 must be going into the dependent current source, a dependent voltage source here. So so the dependent voltage source will be absorbing a current of magnitude 1.6 amperes, and it will be the power absorbed in this particular dependent source will be nothing but 4 into 1.6, that is 6.4 watts. So I've just gone a little ahead and figured out what is the power which is going to be absorbed in this particular dependent voltage source, right? So there seems to be everything is going seems to be correct, nothing is amiss. So I think the figure C is correct. So if there is anyone here who did not understand what I just mentioned or disagrees with me, please raise a flag. Please feel free to interrupt and then ask your query.
Sir, in figure C, it's valid or not?
Yeah. Just as I mentioned, it's a valid figure. The reason is that the KCL is being followed at this particular node and this particular node, and then there is no violation of any rules here. So the KCL is being followed, the KVL is being followed, so that's why it's valid. Did you understand the solution, however? The same person who asked the question, did you understand the solution?
Sir, if a circuit,
Right.
which is applicable to KVL and KCL, it's said to be valid.
Yeah. If the circuit, if there is no violation of KCL or KVL, then the circuit is valid, right? So I just mentioned here why the KCL is being valid at this particular node here, and why things are right. So you can write the voltage source. What's the value of the dependent voltage source here? The dependent voltage source is 2 times I1. What is I1? I1 is an independent voltage source. So it will be,
VS4.
so correct, you are correct. So value is 4. Now what is the potential across this particular resistance? It is 4 volts, correct? From KVL?
Yes, sir. Yes, sir.
Right. So what is the value of current it will draw? 4 divided by 10?
0.4.
Correct. So what is the KCL at this point? If you can apply KCL at this point, what is the current which is coming in?
2 amps.
Right. And what is the current which is going out?
0.4.
Right. So what is the current which is being forced in this branch?
2.6.
No. 2 amperes is coming, 0.4 is leaving. So what is the left out value? 2 is coming, 0.4 is leaving.
1.6.
1.6, sir. 1.6.
Correct. 1.6. So 1.6 will be fed into what? This particular dependent voltage source.
Yes, sir.
Right. And it will just absorb this particular power. Right? Because the voltage source can absorb power or it can release power, just as it was given in the previous question, right? Depending upon the direction of current. So this particular dependent voltage source, the current is incoming into the positive terminal and leaving the negative terminal. That means that this particular dependent voltage source will absorb the power. Correct? Did you understand?
Yes, sir.
Right. So what's the power going to be absorbed? 4 into 1.6.
4 into 1.6.
Correct. Correct. That is correct. So did you understand that every branch and element of the circuit are uh, honoring the KCL and KVL, right? And if I'll say what is the power which is being released from this current source, it will be nothing but 2 amperes into the potential across this current source. Am I correct? The same person who has asked the query, am I correct? What's the power which is going to be released by this current source? If I'll ask you. So feel free to answer. Don't be afraid that you will say something wrong. We are all here to learn, right? Feel free to answer. Please answer.
Sir, I can't get it the question. Can you please repeat it?
Right. So what is the power which is released by this current source? What is the power which is being released by this current source? If I'll ask you, what you will answer?
Eight volts, sir. 8 volt.
No, the power cannot be in volts, man. Matlab power has to be in watts, right?
Okay, हाँ sir. 8 watts.
Right. So how did you get that?
Sir, the voltage across is 4 volt and 2 ampere is the current. So 4 into 2 is 8 watts.
Right. And is it being released or is it being absorbed?
Sir, I think sir it's absorbed.
Why do you think it's absorbed?
Sir, current is entering from positive terminal.
Right. So, but then this is positive here, this is negative here. So if I'll see this particular circuit, the current will be exiting from this positive node, right?
Okay, sir. So sir, the power is released.
Right. So it's just like if it is a source, you see what is the potential across the source and what is the direction of current from the output port of the source, right? And if there is load, you see what's the load anyways is absorbing. And here this is an this is a dependent voltage source, and the direction is current is incoming to the positive branch. Had the direction of current been in this direction, then it would have absorbed, it would have also released the power, but it is absorbing the power because the current direction is 1.6 in this direction. So I hope the figure number C is clear to all of you, and the session would be going offline in just about 3 minutes, right? Because it's Google Meet and it's 1 hour session. So just let me quickly discuss question number, figure number D here, right? So figure number D asks you the validity of this circuit. So this is 3I1. So what is I1? 2 amperes. Right. So YouTube channel link, it has already been given to you by the NPTEL team. I think all of you would have received from them. So let's focus on our attention here, figure number D. So IS1 is equals to 3 times I1. So I1 is 2 amperes. So IS is going to be 6 amperes
amps.
here, correct? And at this particular node, you'll see that current entering this node is 6 amperes here, and current is entering this node from this side is also 6 amperes.
I think it's valid circuit.
No, it's not a valid circuit because there is no
Why, sir?
the current at a particular node from all points of entry must be equals to 0. So I1 plus I2 plus so on up to IN, or you can write also like this, Ij, j equals to 1 to n must be equal to 0, right? So this is the basic rule of KCL, that you cannot have a value of current which is non-zero at a particular node here. So all these currents must add up to 0. You're understanding? So if this current source was minus 3I1, then it would have been valid circuit, because 6 ampere current would be coming in and 6 ampere current would be going out. But then since this is plus 3I1, the current because of this dependent voltage source would also be going in this particular node. So since these two currents are not adding up to zero, it's violating the KCL rule and therefore it's invalid. Did you understand?
So if it's zero, it's valid.
Pardon?
If it is zero, it's valid.
Yes, if it is zero, it's valid. So you are right, if it is zero, it is valid. But since this is not coming out to be zero, this total current is coming out to be 12 amperes, right? At this particular node.
Yes, sir.
So
Yes, sir.
if there is a hypothetical branch here, hypothetically, if you see a branch here, the branch would be carrying out 12 amperes of current, right? So since there is no branch here and then just 12 amperes of current are coming into this particular node, it's not honoring this particular KCL rule and therefore it is invalid. Did you understand that?
Yes, sir. Understood, sir.
Right, because of which D is invalid. So we see that figure number B and C are valid, else otherwise figures are wrong. So the same thing which I have discussed is like mentioned out here in writing, right? So you can see them. So the next question and the other subsequent questions are something which I'll just which are like based on the same ideas which has been taught to you right now, right? So try to do them, and if there are any doubt, maybe we'll clear it off in the next session, right? Because this session is going to end in just a minute, right? Because the time is just running out, right? So it's 9:31 already, and in couple of minutes the session will end. So yeah, so there are basically 2 or 3 questions left for the entire thing which was not discussed here because of the limitations of time. So you solve them and then you come back again next week and you have problem. I'll rectify I'll address your doubts in that particular session. Right, so someone wants to join. Yeah, so I'll encourage you all to join on time, right? That was 8:30 and it would be helpful for you guys because this session is up till 9:30, right? So as I was mentioning, Google Meet is limiting itself to 1 hour, right? And the session is about to end in no time. So so let me thank all of you guys for joining in. Did you find, let me get some feedback here. Did you find this interaction session to be useful?
Yes, sir, it is useful, sir.
Okay, that's great. That's great to hear. What changes I can do it from my end to better this interaction? What suggestions do you have? Any suggestions?
While deriving the sums, if use formula, it's convenient for our.
Okay, you want more formula, right?
Yes, sir. Yes, sir. It's convenient for all.
Okay, I'll try to incorporate more formula, but what I have figured over my years as a student and then as a PhD student also is that you must understand the concept behind those formula. If you are not able to understand the concept, that is a real problem, because a formula you can like easily work it up, right? But then the concept should be clear. So I'll try to have a healthy mix of both those things from the subsequent interactions.
Okay, sir.
Yeah. Any else? Anything else? Any other feedbacks you guys have for me? So there's 18 students here, 18 or some 20 students here. Feel free to voice your opinion till this platform is still active.
Sir, is NPTEL lectures is sufficient for GATE preparation?
So those kinds of questions, I'm afraid I'll not be able to answer. Right? Those questions, the best person to ask is your supervising professor. So this particular coursework is being facilitated by some particular professor. So you ask these questions to him. Based on my personal experience, yes, it is. Yes, it's sufficient. So I think many of you are joining in now, and then the session is about to end. Like I think it has been notified to you that this session was supposed to commence from 8:30 onwards, right? And yeah, for some strange reason, Google is allowing me more than 1 hour. So it's strange. Uh, Previously, it used to end sharp at 1 hour. Okay, that's good. So quite a few of you have joined here. So I think one of my colleague is about to take a session right from 9:30 onwards. So she would also have floated her link, right? So if in case this session ends and you still want to interact, you can join her session from 9:30 onwards. So it would have already commenced on some other Google link platform, right? So, thank
So
you.
where is the link for 9:30?
Pardon? Pardon?
So what is the link for the 9:30?
9:30, it would be provided to you by the NPTEL team, I guess, right? There would be two links which would be provided to you, right? Or I'm not aware of how it is being. So everyone is joining in this particular session. Okay. So this was supposed to be an hour long session. So as I was just mentioning to the other guys, I'll be ending the session very soon, right? So I encourage all of you guys to join in on the time that is 8:30, and the session will be carrying on till 9:30. Oh, okay, okay. So maybe when I'm saying 8:30, it's a little confusing to you. This is because I'm sitting here in US, so there is a time difference between your timing and my timing. That's why. So in my clock, it's 8:30 a.m. and in I think IST it will be 6:30, something around that. So yeah, so it's an hour-long session. Regardless of that, it's an hour-long session, and then. I encourage you all guys to commence, like join the session at that time, right? And it will extend till 1 hour from the time of joining, and post that I'll be ending the session. So I have discussed some 10 questions or 9 odd questions with you guys. There are 3 remaining questions. The links to the discussion, I'll be uploading it on YouTube. Feel free to see them again. If you have queries, feel free to raise them next time when we join. If you have any doubts in the remaining 3 questions, feel free to raise them the next time we join, and I'll try to address them. So with that, and I have taken a mental note of the points which was raised regarding more formulas by one of your colleagues here. I'll try to have a healthy mix of both the formulas and the concepts here. So with that, let me call it a day. Thank you all for joining in, and have a good day.
Thank you, sir.
Right,
Thank you, sir.
right. Thanks for joining in.